All right, everyone, we'll just go ahead and start. Welcome to Maximize Productivity, Minimize Waste, Revit for Prefabrication webinar. Before we jump in, I just wanted to start off and introduce Microdesk to you all. So Microdesk was founded in 1994 as an Autodesk reseller with a simple mission to assist architecture, engineering, construction, owner and operations, and GIS firms with improving workflows and integrating project delivery technologies. And 25 years later, that mission still holds true. Microdesk is a well-established AEC consulting firm with 13 offices in the US and the UK. We have over 200 consultants, solution specialists, and software developers. One of the hottest topics in the AEC world is actually urbanization, urbanization suggests that the US will build 114 cities the size of Boston in the next 30 years. And here at Microdesk, we can help make sure that you are prepared to meet those demands. We use software from industry leaders such as Autodesk and IBM and combine it with our vision and passion for sustainability to meet the demands of urbanization. Our team of industry expert consultants are redefining project delivery and asset management. And to help support the industry with these demands of urbanization, we provide full service consulting that includes building information modeling services, enterprise strategy and workflows assessments, technology management, mentoring and support, and application development. So now I'm going to let Jeremy Byrd, the presenter, jump on and take you through today's webinar. Thank you, everyone.
Hi, good afternoon, everybody. This is the prefabrication webinar for Microdesk, as I previously stated. My name is Jeremy Byrd. I am an architectural solutions specialist for Microdesk. I've been at this career for over 17 years, growing up around, architecture and construction myself, using BIM, BIM 360, cloud technology, and then, becoming a certified professional Revit user. I've kind of been through the hoops and challenges. And, today is so much about Revit, about how we use Revit to, deliver an end product to our customer with great results. So, we have a few queries here. What exactly is prefab? On the very left-hand side of things here, we see, a very bad example of prefab. We have, travel concerns, so we see a tiny home. This is a type of prefabrication. The next section we see, in the factory, underneath there, we see modular housing or mobile housing being built. And then on the right, we have a project that I worked on a number of years ago, which I will call my test case scenario, in which I was the architect, the construction manager, and kind of like the overall steward of this project for a company you'll later hear about in this presentation. There's so much about prefabrication that, it doesn't have to be any of these things that you see here on the screen. As we will find out later on in this webinar, prefabrication can even go down into the micro components, such as a wall, being able to build those offsite in a factory, bring them out, prefab those walls out in a factory or out at the, a contractor's warehouse, and being able to wire those up. And we could talk about kind of what that means to our industry. We see that happening in not only smaller projects, but homes, stadiums. Prefabrication is the hottest trend as far as being able to do things slightly different. When we talk about prefabrication, we talk about controlling the environment. And what I mean by that, there's no rain days, obviously, if you're inside of a building. Being able to have your tools on hand, There's just so many kind of variables that we can just take away from, you know, the the site aspect as far as how can we optimize the process along the way. And these are kind of some questions that I've kind of put together in kind of discussion and design topics. And what is prefab? How does it affect what we do in Revit as architects, as engineers? That's kind of the overall reaching general question. And then it goes into what does it mean for the design and coordination process? As an architect, that's, I want to know kind of what's going on there. What do we have to look at as architects and designers is we're putting something, prefabbing something off site, putting wheels underneath it or putting it on a trailer. What are we looking at as far as trying to get stuff out to site? And then we talk with a lot of modular or mobile or prefabrication companies. What does in the factory mean versus in the field mean? And then can modular construction be green and can it be cost effective? Those are kind of some general questions to think about throughout this entire webinar. It's kind of like this discussion topic, the hot topics. So I want to show a little video that, we had put together for a project I worked on for Starbucks. Now, this project was worked at back in 2012. This is something I was involved with very intimately. And like I said, it was everything from the design process. This was a large program, so there was multiple of these that we kind of kicked out. And it was kind of, what modular to me at the time was. We had built these units off site for another company I was working for at the time. And I kind of became a pseudo expert for modular construction. So what happened is we built these micro stores for Starbucks and we were pulling these out on site and we would build these in the factory and literally ship everything inside of them. Everything from equipment to rooftop equipment to, how can we as architects challenge the design process when it came to modular? You look at it, it's green, it was LEED certified, it was put up in 2 weeks. So, you see a big dirt field on the site now, and then within 2 weeks, you have a completely operating functional store. What does that mean for us as architects? How can we challenge that design process? How can we come up with something cool that is local, that is built in the factory, that is built cost effective, that is built green? Green is such a hot topic lately, and it's like the bingo word of the day is, is this sustainable? Is it green? Is it delivered on time? Are we using the tools we have to come up with something really, really cool, off-site, modular, green? Let's take out the the variables out of it and build it off-site. So one thing I wanted to talk about is travel concerns. This is another example of a similar project that we built. The one that you've seen before was built out of a container. This was built out of standard construction off-site. And where we're moving these things over the road, what do we as architects look for, and how does that kind of key into our design processes? So travel concerns: width, height, length, and weight. Those are the 4 key points when moving something over the road. And kind of every state is different, so I would suggest that you do, some local code research, whether it be through the DOT, through your local jurisdictional and government agencies. But, in Michigan, for instance, anything that is over 8.5 feet wide, 12 foot 6 inches in height, 45 in body length, which is the module length, and 60 feet in overall length, including the towing truck. Anything outside of those regulations require a special permit. Um, so, if you try to move something over 16 feet in width, 15 feet in height, and 80 feet in body length or over 105 feet in overall length, it requires a special permit. Anything beyond that, they will not allow you to transport. Modular companies, prefab companies, people that are building these, modular office complexes. I've seen bathrooms prefabricated off site and then pushed inside of a building that's built on site. Those widths of those modules typically range between 10 and 15 feet wide. And this is per the North American Modular Association, I do believe. But it depends upon the variance allowed by the local, state, and transportation board. So, I'm not an expert in every single state. So again, those things will have to be verified. You can see here that I found the Michigan reference down below, and I've cited that, and that way you guys can reference that later. So, what do we look at for, codes? Well, I was designing a programmatic approach, which means we could take this building, we could put anywhere in the US, and I want to design for the 90% case. So as architects and designers, we know that, not everything is going to be a programmatic approach. But if you're going to try and design something that can be made by multiple different manufacturers, you can approach different manufacturers, you can, spread this design culture that you're trying to build across the United States, like we were with the Starbucks program that I worked on. We looked at designing for the 90% case scenario. We created this table for the project, and we would cross-check all the codes and kind of how that fit in. We had a master set that had not only the IBC, but California building codes to Miami building codes. So we could pop those in and out of our Revit model. And I don't want to talk so much about, semantics and small things and, how I'm going to pull things into Revit, because most of us already know, well, what I would assume is, we're interested in BIM. We know what Revit can do for us, but how does it apply to us? Revit allows us to store that information like a giant database and then push that information into the model and say, okay, it's going to go here. We're going to just, pluck this information out because we don't need that information. We're going to pluck this information in and see how it, kind of tweaks everything. I'm telling you right now, it wasn't a really big square footage. It was 372 square feet, I think is my total building area for this little guy. Another thing that I want to say is, look, we're designing a modular. How do we, this is a modular. How does it interface with the site architect? And as you can see here, what I have is basically a reaction summary. And this is where the modular would, connect to the foundation points. So we would sit these on a pillar foundation. And you can see here, there's a little diamond, here a little diamond, diamond here, and here. And that kind of continued around the building, and that would allow us to interface the module with the site conditions and say, hey, this is kind of how we're interacting with each other. It's all drawn in Revit. And as you can see, this is a fairly detailed style floor framing plan. When we build things at factories, it's not always, a senior carpenter that is putting things together, a senior welder. A lot of these guys are factory workers, so they need a detailed set of instructions of what does that mean for Revit. Another thing is, I said in the beginning, what is in the field versus in the factory? So we had installer notes, kind of bold in red, for lack of better term, for those installation pieces and parts. And it allows us to see the differences between what is in the field and what is in the factory. So everything in a normal black color on this sheet was stuff that was done in the factory and installed in the factory. And you'll see over here on the very right, there's this nice big installer note over here that says, hey, this is a site item. You need to install these pieces in the field for this structural system to coordinate with each other. And this was kind of a process we developed with the local governing agency, which we'll talk about a little bit later, because modular is somewhat handled a little differently than a regular construction would be. So this is another example. What is field versus factory? This is what we have to deal with in the design coordination process. So this was along our moment in shear reactions for the structural drawings. This would say, hey, you need to reference this detail out in the field here because there's something important that's going on with this strap that's going along here. And can show you how we can kind of automate this structural drawing process. Again, these are framing elevations that are done for the factory. And the reason why those are done for the factory is because you need to know every little piece and part in order to build these things like Legos. And then if we reach back even further in our mind and we say, hey, all construction is modular. Well, what do I mean by all construction is modular? We're building these things from a kit of parts. We have standard W sizes. We have standard sizes for lumber, 2x4, 2x6. We have standard lumber sizes for sheathing, etc. So we're building a Lego kit of parts somewhat to that effect. And a lot of times how these manufacturing facilities work is they'll go and they'll cut all of the studs for all of the walls. And they'll say, okay, I need 26 studs, 10 feet 6 and 5/8 high. And they'll slap these walls together in a jig and build those. We can get into that a little later as well. So here's another great example of kind of field installer notes. So we're talking roof here. So this is a roof framing plan. This shows, a Simpson CS 16x36 centered on post and header as required in factory, reference elevations for vertical locations from finished floor. So this is telling me that I'm going to factory install part of this, but then I'm going to finish the connection over here in this detail. Again, it's telling you to provide bolts all the way across. Again, it's just a difference between factory and field and that design coordination that needs to happen in order to make things work, relatively easy on site for the people that are working with you guys. Design coordination, it's all in the details. What do I mean by that? So we have this canopy. So this canopy was a bolt-on accessory to the exterior of this building. It was prefabricated off-site by a local awning company. Well, we're going to drag these things across the nation, so we need multiple local companies to build these pieces and parts. And how are they affected? Well, let's just go ahead and give them the assembly details over here for all of the metal pieces that are going on. And then let's just tell everybody how they're, attached to the building here on site. Another big thing here is responsibility. So when you're designing a modular, you have in the field, in the factory, and what happens if you have some client supplied equipment like specialty IT equipment, security system, who is going to be setting the building, whether it's going to be the general contractor, the modular company, whether the client is just buying the building from you. This is another thing that is easily dealt with in Legends in Revit. Here, you can see that there's different areas of responsibility for each individual person. I'm not going to go into specifics on how to create that schedule during this webinar. This is the awesome piece of Revit. This is what Revit kicks out as part of a schedule for you for specialty equipment. And as you can see, here, there's a responsibility matrix. And this is where, what we were responsible as far as specialty equipment. Everything else was client supplied. It should be ordered, whether it's shipped to factory or shipped to the site, whether it's installed in the factory or installed on site, and who it's installed by. When you have things like soda machines, etc., some of those, as far as food service goes, some of those pieces are installed by the actual equipment vendor themselves. So this is a really, really great example of what it looks like in a factory. When I say in the factory, this is one long module here. You'll notice on the left and right, you have two large yellow cranes. Those are gantry cranes. They're used to pick up walls into place. They're used to move men back and forth. What we're doing here is, this goes back to, is it green? You can see here in the background, we're using blue jean denim insulation, which is highly sustainable. It's made out of recycled blue jeans and cotton. We're using all FSC force certified, wood products. We're going with, high reflectivity roof, recycled steel. We're going with recycled aluminum for the windows. We're using Tyvek on the side to seal the building up. There's just so many things that we can do just as well in a factory as we can do off-site. However, if it's raining outside, it's still not going to cancel your day because the entire building is literally being built inside of a factory. All the tools are on one job site. It's going to reduce the number of trips you have to go back and forth from your office to the job site, or from a contractor's office to the job site, therefore reducing your carbon footprint. Everybody loves that. It's going to put everything at your disposal. And another cool thing about building in a factory is going to be, you reuse a lot of this stuff. So if you have a 2-foot piece of board, you're not going to throw that back in your truck and take it back to the office and use it along the next project. These guys literally have bins of, wood that they pick out of for blocking, for, setting these up in what I would call their yard. We can go into that a little later. So here's another great example. This is something that I would draw for the factory. This shows the exact heights of each piece of plumbing equipment here. And you'll notice over here, I still have the same thing up here in the top corner. Whose responsibility? Should it be ordered? Where it's shipped to? Where it's installed at? And all of that good stuff. So here we go again. Here's that great Revit schedule. 90% of what we do in BIM is so we can export a great schedule as far as an architect goes. We can go into, coordinating, elements and heights, such as, using BIM to our advantage to set the height of a wall for a receptacle. We can set the height. We can get everything put together, see how it interacts. And that way we're, coordinating our stuff before it hits the field. The stuff is all built in the factory. And you can see this is one module that I worked on. How important is BIM in this process? You have a 48-inch by 12-inch deep duct that is literally sandwiched up against the ceiling of this container, how are we going to get, water from one side to the other, electrical from one side to the other? How is all this running? How am I going to fit all of this into such a tiny space? Modular makes you think about coordination. How does BIM, affect, or how does BIM fit into the prefabrication role? Everybody thinks, oh, this project is so small, I don't understand why we're using BIM. Well, it is so small, and it's even more important to use BIM and Revit, for that matter, to put things together on the computer before they hit the ground floor. Because once they hit the ground floor, it's over. So what does in the field have to do with what we do in Revit? And this is the biggest talking point of the day. So you'll see here that this unit is 25 feet in the air. It's 25,000 pounds. And you see right here what's going on. Those are all of the electrical pieces. You see the return here, you see the supply here. How are we going to make sure that those two pieces connect in the field like they should, how they should, and where they should? The answer is Revit. Revit will allow you to align a duct to a specific point based upon where the module is sitting. Give me just 1 second, I can show you. This is another element. What does it have to do with Revit? Well, we have to design this connection, so we need to know how these modules sit together. So you have unit A here and unit B here. This is a mate line detail for the roof. How do these elements fit within each other? How do we seal those pieces together? What is going to happen here? Everything we do in Revit has to match with what we do in the field. Otherwise, you're going to have angry individuals, and we all know how that can be. Here again, so we have this pipe, which is prefabricated into the wall with an elbow in it. And the rest of this here, including the floor sink, is site set. So this is coming up. You have your horizontal connection here, and we need to connect to the vent that's going up. So how does this building interact with the site once it hits there? So what I want to talk a little bit today is, PowerPoints are great, but when it comes down to the details, how do we do some of the things we just talked about in Revit? So I'm going to pull up Revit real quick. We can look at some test case scenarios. What I talked about earlier on was, how do we prefabricate certain things off-site? Maybe it's not an entire building. This is modeled in Revit. So as you can see, this tells you on the stud, I want to prefabricate X wall. Well, how long is said wall? We can find out by selecting this track down at the bottom. Cut length is 10 foot 6 3/8. Well, if we count how many studs in the wall line, this will tell you exact height of those studs. So if your top and bottom plate are set, we know that we could build these, and we could, prefabricate these walls off-site. We could do a, wall elevation, come up with wall drawings for each individual wall, and fabricate all of those walls off-site. And for that matter, if the electrician wanted to, we could set the heights of the holes in the wall studs and prefabricate half of our electrical off-site and just do the connections once we get on-site as well. So this is a good test case scenario. And this brings me to another point. What tools are available to help us? This is a program that I've used in the past. It's from AGA CAD. They create add-ins for Revit. This allows you to create smart walls. It allows you to create cut openings. it allows you to create wall line drawings. So you can select a wall line, it'll do an elevation for you, it'll tag all the clips, it'll allow you to build the wall how you want. And you know, we're talking about, now we're going to go into the modular aspect of things. How does that affect us? Well, here's a great map from T.R. Arnold and Associates showing you that they have, you know, either third-party inspection, whether it's a state plan review and state inspection, state plan review and third-party inspection. You know, there's all these different scenarios. So you have either state inspected, state plan review, third-party plan review, third-party inspection, local plan review, and local inspection. Third party is typically a company you hire from outside to do your plan review and inspections, and they are approved by the state to come in and look at that. And the reason why I bring this up is because what am I going to draw in Revit? How am I going to approach that? Who is my audience when I'm drafting in Revit? So, with that said, we're going to look at this and we're going to say, okay, well, how do I set boundaries inside of Revit where I understand, you know, whether my module is going to fit within those length, width, and height restrictions? Well, I'll show you. I'm going to open this module here. I'm going to unload it from my project, and I'll show you kind of how I have things set up. So I kind of built this as a test case scenario, 12 foot 6 high from start to finish. And we use a travel depth of 2 feet. So what I mean by travel depth is you're going to have a carriage that sits underneath the module along with tires and wheels. So you have to account for that when you're accounting for over the road height. And how do I find that dimension? Usually I find that dimension by talking with a modular manufacturer. Or if you are a modular manufacturer, you will know what your height and width and depth parameters are based upon your local DOT, you know, regulations. So we're looking at Revit and we're saying, hey, you know, how do I know my overall, you know, length, width, and height and floor plan? What I like to do is I like to just set up grids here. It makes life easier on everybody. We know that our truck's about 15 feet long. Our overall, without getting a special permits, 60 feet. So I'm going to say I'm going to draw my module with 45. But you also have to be mindful that none of the siding can stick beyond that 8 foot 6 inches in width. None of our add-ons, bolt-ons, extensions, or anything can extend beyond the box that I'm showing here. 8 foot 6 in width, 45 max. So what I'm going to do here is I'm just going to pop in a few things. So what I'm going to do is I'm going to place some items here. I'm going to place a component, load family, and we're just going to go over to plumbing, architectural. Let's just go fixtures, and let's insert a water closet here. Nope. Nope. And I'm going to insert a couple more components here. So, you know, we got some water closets here. Yippity. What I'm going to do here is I want to create a schedule very specifically for you. So I'm going to go view, schedules quantity, and create a plumbing schedule real quick. Plumbing fixture schedule. And let's create a type mark in here. Let's go to description. very basic plumbing schedule here for you. So we know we have elements 1, click OK. It's going to change those 2 elements, elements 2, and click OK. Go back here. We know that by looking at these elements, oh, what did I do here? Wonderful Revit trick. If you click the wrong button like F1, it opens a window for you. So we look at the type mark for these tubs. We know that they're type mark 2. We know that the water closets are type mark 1. Water closet. And I'm sure that, you know, with your firm that you have specific, you know, families that you guys use. Okay, so how do I tell Revit something's installed in the field or factory? What I like to do is I like to just create a new parameter. And depending on whether it's an instance or a type parameter, I call it an instance parameter because it says field or factory. So what I go here is I type under the parameter data, field. And we're going to create a yes/no parameter. And we're just going to create it under other for now. Common discipline. And we're just going to create a project parameter and click OK. And this gives me a quick and easy kind of on and off toggle. So we can say plumbing fixture schedule, click overall. You can name it anything you would like. And we're going to look over here and we're going to say, okay, well, we got a plumbing fixture schedule overall. We're going to take and we're going to duplicate. Oh. Duplicate. Oh. And we're going to rename this field. And we're going to rename this one factory. Well, how does that affect me? Well, that affects me by, you know, takeoffs. So what we have is we have field, we have overall, we have factory. So I'm going to go to overall. I'm going to change these 2 here to in the field. Okay. Now what we want to do is we can go over here and we can sort and group those. Filter by field equals yes, and click OK. And now only my field installed items show up on this schedule. And I can go over to factory and I can go to filter and I can say field equals no, and click OK. So what that tells me is that these items are installed in the field. We could have a schedule sheet dedicated just for the field people that they can cross-check their items before they leave the factory. We can have plumbing schedules work this way. We can have casework schedules working this way. We could have pretty much any schedule in Revit saying, okay, I need to gather all of these items and bring them out to the field with me, which reduces the number of trips out to the field. Therefore, again, you're saving money, you're being green, you're being earth conscious, you're being everything that everybody wants you to be as far as, you know, LEED and green and governmental and jurisdictions. You know, there's so many things that we know we can do in Revit, and it really is up to the individual on how you implement these items to be prefabrication friendly. We know, the field guys know what the field guys need. The factory guys know what the factory guys need. And the most important, you know, element to this is BIM and architects and engineers and plumbing designers and mechanical designers is how all of this interacts and meshes. We could do so many things within Revit to make our lives easy, and using schedules is the biggest key, I think, to Revit and prefabrication. It can tell us what we need to bring out to site. It can tell us how to build things in the factory. It can give us precise dimensions and takeoffs to allow us to estimate our project better. There's so many things that BIM can do today that wasn't available back in 2012 when I was doing this project, this test case scenario, that are now available to us as far as extensions to make our lives easier, and the premise for moving BIM forward is to create an environment that all of us want to live in. It's to make our lives easier at the end of the day. It's to be able to see things in 3D and put all these parts together while creating a beautiful InDesign for the client. BIM is just as relevant in prefabrication as it is in the 26-story high-rise, if not more prevalent, due to the space constraints and sites that we see a lot of these modulars being dropped into. We can drop a modular into a site 50 feet over another building without even touching it via a crane. We can prefabricate walls off site to reduce the amount of trips from job site to office. We can build it green. We could build it in the factory. We could build it on site. It just depends upon our site constraints. BIM will work for prefabrication. It can work for small elements, large elements, multiple elements. As you see, I would like to take the questions, if there are any questions. So what are my thoughts on using Revit assemblies for shop drawing creation? That's the only question I see right now. I'm not sure if there are other questions. Jasenia, if you're still with us, you may be able to help us get those questions. I typically use Revit, and I've used Revit assemblies for shop drawing creation. And by doing that, I create families that are detailed and have all the pieces and parts and elements in them, especially if it's something that I can stretch and modify and move for creating those elements. When you're detailing in Revit, you're just as well as detailing in Revit than any other software. So I don't know how that interacts with exactly what you're talking about. If you want to give me more information in regards to what exact assemblies you're using for shop drawing creation, I might be able to answer better. And if I don't have any further questions, I will give you guys the gift of time today. Thank you guys for joining me and my rant along the way of Revit for prefabrication. As you know, it is important to do things prior to the construction process to make everybody happy. If you are interested in hearing more from us, you can check us out on our website at www.microdesk.com. We're always available by phone at 1-800-336-3375. You can email us at webinars@microdesk.com. We're across the US. I can see a couple dots on here that I know that are filled that we don't have shown on the map. You can connect us with us via YouTube, LinkedIn, Facebook, Twitter, and Instagram. We are literally everywhere on the web. Thank you all for joining today's webinar. I hope you have a wonderful rest of your day, and we will talk shortly.